a simple example. Yeah, let's start with a very simple example. Then we'll complicate it. Okay. So let's say we have a road here. Okay. And let's say two cars are moving. Okay. This one is moving with some velocity. Let's say v1. This one is moving with some velocity v2. Okay. And there are people in both of them, right? So a person who is standing outside, let's say object A and B, A will appear to move with velocity v2, no, in forward direction, and B will appear to move with velocity v1 in forward direction. This is our fixed frame. Okay. And both these velocities are what velocities? These are absolute velocities, you know, absolute velocities. But when we are, talking with respect to A, so A is sitting in this car, right? And for A, all the parts of the car are stationary with respect to himself. So for a person O here, the complete car is moving along with the person. But for a person A, the car parts in which he is sitting, all those parts are at rest with relation to him. So the velocity of the car with respect to the person inside is 0. Are you getting? Yeah. When you are sitting in the car, everything around you will be moving along with you, no? Even the car is moving, you will feel if all the windows and doors outside world is close to you, then it will appear to you that the car is at rest. Then let's say V is moving faster if V2 is greater than if V2 is greater than V1, and now he is watching the person at B. Okay, the person in A is watching the person in B. Then what will happen? The person at B will be slowly moving backwards with relation to A, no? Because A is overtaking B, right? Yes. So because V2 is greater than V1, A is moving at a faster rate, and B, for A, B appears to be slowly moving backwards. Okay. So this velocity is called velocity of B with respect to A. Okay. And what will be that velocity? What will be that velocity? That velocity will be V1 minus V2. Okay. And since V2 is greater, we will get a negative value, you know. And because of that, B appears to be moving backwards. Okay. And if you want velocity of A with respect to B, that means now B is observing A. B is observing A, you know. When B is observing A will be slowly moving in front because it is overtaking. And that velocity will be V2 minus V1. Correct? And we will get a positive or negative? Positive. Okay. Understood the relative velocity? Both are moving front. V1 and V2 both are moving front. But V2 is greater. That means A is slowly overtaking B. Okay. And we are talking about relative velocity of A with respect to B. When we talk about absolute velocity, velocity of A will be equal to V2. Velocity of B equal to V1. Okay. And if you want to write, let us say, velocity of the observer with respect to A, velocity of the observer with respect to A, what will this velocity be? Hmm. Observer is fixed. He is not moving. Yeah, his velocity is absolute velocity is zero. But for a person who is sitting in A, for a person who is sitting in A, this person appears to be moving backwards. No? That velocity will be equal to minus v2. Yes, got it. So one last one. So velocity of O with respect to B. Negative v1. Okay. It's slightly confusing. So what we have to think is we should assume that the person who is reference, he should be assumed to be stationary. And with relation to this person, how everything else around him is moving. That's what we have to see. Okay. So nothing is absolute. Everything is relative. That's what is true, right? So for example, one simple example, I think this will help you in understanding it better. Suppose an astronaut has gone into space and he comes back after a long time in space. Okay. So this person, when he is moving on the stairs on Earth, fine, he will feel as if he is pushing the ground downwards. He will not feel he is moving upwards. He will feel that he is pushing the ground downwards. Okay, because he has got used to zero gravity. No, in zero gravity there is no up, there is no down. And after spending 1 or 2 years in the space, when he comes back and when he is moving up, it will appear to him as if he is pushing the ground down. It will appear to him that the ground is moving down. Right? Understood now? Because in zero gravity, he will become the observer. You know? And everything will move around him. But when we are on Earth, Earth is stationary. Earth becomes observer. You know? And everything will move relative to the Earth. Yes. So did you understand what is relative velocity? I think the crux of it you have understood, but there is still some doubt about how to take it. So I think with problems we will be able to understand it better. Yeah. Okay. So RA you understood now. RA is the absolute position of A. Okay, with respect to the fixed. This is how. Yeah. Suffix. If there is a single suffix, that means it is absolute position. If we write the suffix like this, B/A, that means this is the position of B with respect to A. Okay. So here what I have done is I have taken a one-dimensional motion, right? So here we have taken one-dimensional motion, but here three-dimensional motion is happening. And here I have shown you only velocity. Here I have shown you only velocity. But here we have to show everything. First we have to start with position. After position, if you differentiate it, you will get velocity. And if you differentiate velocity, we will get acceleration. Okay. So everything starts with the position. So you understood RA is absolute position of A. RB, yeah. So B, again, yes. Mm. Yeah. So here, that's what this line represents RB. So both RA and RB, they are appearing, they are starting at observer, right? That's what is absolute position. Okay. But when the person A is observing B, then it becomes position of B with respect to A. Okay, and this is how it is written. A is observing B, so it will be RBA. If B is observing A, then it will be RA/B. Okay, that's what we discussed here now. When B is observing A, 1 minus 2. 1 is B, so it is B minus A. Right? And when A is observing B, it will be A minus B. Okay, so B comes first. Here also B comes first. The order is same, right? And when you see this, when you see this, you should read it as position of B, and slash means with respect to. Slash refers to with respect to velocity. Position of B with respect to A. That is equal to absolute velocity, absolute position of B minus absolute position of A. Okay. And see here we have one more example. So this is elevator, right? I think it's a horizontal elevator. People will be moving forward in the line, right? So fixed reference plane is a person who is standing on the platform. Okay, so he is stationary and he is watching two people move on the on this elevator. So now RA is the absolute position of A, you know? And if the observer is watching another person B, that will become absolute position of B. But if the person A is watching another person B, because both of them are moving, right? That becomes relative motion. That becomes relative relative position. Because here we are measuring position. You know? That's what he is rating it as. The position of B with respect to A. Okay. And that value, yeah, so that value will be equal to RB minus RA. Okay. Same way, velocity also will be same. So velocity of B with respect to A will be velocity of B minus velocity of A. So he has just rearranged that. So same way as if we send RA to the other side, it becomes RA plus RBA. You know? The same thing he has done here. Then relative acceleration also is the same, right? You first remember this thing, then everything else will follow. Okay. So here velocity of the plane, velocity of plane with respect to aircraft. Which one is aircraft? Which one is plane? So this is an example of fuel transfer happening between the jets, right? So for the fuel to be transferred, both should attain the same velocity. Only when both attain the same velocity can the fuel transfer occur. So here I think he's explaining the same thing. So the velocity of the plane, one of them is plane. Let's say this one is plane or this one is aircraft. What is the difference between plane and aircraft? Plane is larger one. I don't see any difference between them. Anyway, so one of them is plane, one of them is aircraft. Okay. The velocity of plane is equal to velocity of plane with respect to aircraft plus velocity of aircraft. And yeah, so if you want the fueling to occur correctly, velocity of the plane should be equal to velocity of aircraft. And when you substitute these here, the left side and right side will cancel out. And we get velocity of plane with respect to aircraft as that will become 0. Correct. So here we have a first problem. Let's take it. So train traveling at constant speed of 9 km per hour. Velocity of train is 9 km per hour. Crosses the road if the car A is traveling at 67.5 km per hour. Okay, so here we have a car A which is traveling towards this bridge. Okay, determine the magnitude and direction of relative velocity of train with respect to the car. That means we have to find car. Car is written as A, train is written as T. So V velocity of train with respect to car, VTA. So yeah, so for this, what we have to do? It will be V yeah V of T minus V of A. Now we have to define VT and VA. Okay, how much is VT? Now look here 45-degree angle is given, right? So we have to take some references fixed. So I think this is the observer. Okay, this is the observer. So with respect to this, we need to measure it. So VT will be only in x direction, right? So that means it will be 90 of I, right? But the car A is moving at an inclination, right? This angle is 45 degrees. So yeah, so velocity of A will be some value in x direction, some value in y direction. So what value in x direction and what value in y? X component will be cos 45, no? So 67.5 into cos 45. This is I, and then plus 67.5 into sine 45. This is J, correct? Now substitute both of them here, you will get it. 90I and then minus 67.5. Cos 45 is root 2, 1 by root 2, no? Then this will also become minus because brackets when you open, minus gets multiplied to both. So minus 67.5 again by root 2 of J. So you can take I common and find this. What do we get? 90. Sorry. Find the value in decimals. But 42.27 I minus, calculate this as well. What do we get? 47.73 J. Okay, so this is the velocity of train with respect to car. What will be the velocity of car with respect to train? So that is reverse of this, no? So we can also write it as minus VTA. So now you just have to multiply negative sign here. So minus 42.27 I plus 47.73 J. That's it. So this problem is clear. That's what he's explaining here. You can see we are getting the same answer. Now he's also asking magnitude. Did he ask magnitude before? Yeah, he's asking magnitude. No, we just now found the this is vector. So if you want magnitude, velocity of t with respect to a, that will be under root. What do we get? 63.76. This is in kilometer per hour. Correct? Now this is the magnitude. Kilometer per hour, no? This is magnitude. What about direction? You want to show the direction graphically, then we have to use references, no? X axis, then y axis, right? Now if you see x axis is positive, no? X axis is positive 42.27, right? And y axis is negative, so it is downwards, that is 47.27. If you want to show the the velocity, it will be in this direction, right? And if you want to show the direction, you have to measure this angle alpha. Alpha will be 47.27 over, yep, that's 73, 42.27, 47.73. This is in degrees, right? That's the solution. He is also getting the same 48.40. 48.40 is getting. Maybe slight error is there. He has rounded off to one digit. Okay, that's the reason we are getting a different slightly value. And the example 2. Let's take this example 2. So this one is on aircrafts, right? Okay. So we have a plane flying along a straight line. Okay. So plane A is moving in a straight line, while plane B is following a circular path, having radius of curvature. Radius of curvature is given here. Find the find the velocity and acceleration of B as measured by the pilot of A. Okay. Velocity of B with respect to A and acceleration of B with respect to A. So yeah, so both of them we have to take here. Okay. So for this first V of B with respect to A, if we want to find, we have to first find velocity of B and velocity of A, correct? Let us find them first. So velocity of B is how much? It's moving upwards. It's upward means velocity of B is 600 kilometer per hour. In which direction? Along y direction, huh? Along y direction. Okay, 4 kilometers is the gap. Will it have any velocity in x direction as well? At this instant, when it is moving parallel to y-axis, then all the velocity will be in the forward direction. But if it is moving to this point, then it will have both x and y components, right? I think we are asked to find the instantaneous velocity only. So at this instant only we have to consider it. Okay. At that instant, velocity is 600 in direction of y, so it is j. Then velocity of A, again it's moving 700 kilometer per hour. Again it is parallel to y, so it is j. So substitute them both here. So it will be 600 minus 700. It will be minus 100j. That means for A, the pilot who is sitting in A will watch B moving downwards. Because he is faster. So B will appear to be moving backwards to the pilot inside it. Okay. Acceleration is not going to be that simple. So you have to be careful with this. Okay. Acceleration of B with respect to A when you want, it will be, yeah, slow means it will be moving backwards, no? Because he is overtaking B. He is moving faster and he's overtaking B. So B appears to be moving backwards slowly. Now for acceleration, it will be acceleration of B minus acceleration of A. And accelerations are not simple. So when you want acceleration of B will be combination of two accelerations, right? Tangential acceleration. Let's write here itself. Tangential acceleration plus normal acceleration. Okay. So what is the tangential acceleration? Of course it is tangent to the curve, but what is its value? How do we find it? Oh, that is normal one, no? Normal is same as centripetal, right? So tangential is given here directly. Actually we have to take it as dv by dt, right? Yeah, of course it has to be tangent to the curve, and its formula is dv by dt, rate of change of linear velocity. And yeah, and that value he has given directly. So this is our tangential acceleration. So but it is acting in downward directions, we have to take it as minus 100. Okay. And normal acceleration always it acts towards the center, no? Towards the center, and its formula is v square over radius. So radius of curvature rho. not T, it is Greek alphabet rho. Okay, so V square by rho. So substitute them, you will get it. Mine, oh, 1 minute. Yeah, and that is in J direction. As tangential is in J direction, but this one will be in I direction. No? So plus velocity. Velocity of which one? Velocity of B, no? Velocity of B is 600. 600 square divided by 400. This is the value of acceleration and it is acting in x direction, so it is I. So simplify this, what do we get? Minus I value, let's write it first. So two zeros will cancel, it will be 600 by, sorry, 3600 by 400, right? 600 by 4, sorry. So 900, so 900 I minus 100 J, correct? This is acceleration of B. Now we need to find acceleration of, A. Okay, acceleration of A. So A is moving in a straight line, right? And he's giving the acceleration. Normal acceleration will be 0 here. Hmm. So yeah, 80 plus an, but an is 0 anyway, so we can directly take it as 80. So velocity of A, 80. A, that is how much? 50 per hour square. Acceleration is hour square, no? And it is in which direction? It is in y direction, so we have to take it as, yeah, it is positive and it is multiplied to J. Both these values, if we substitute, we will get B with respect to A. So acceleration of B minus acceleration of A. Acceleration of B is 900 I minus 100 J, then minus 50. So it is 900 I minus 150 J. Okay. And once again, if you want to show the direction, what we should do? X direction is forward, right? X direction is forwards, downwards. Okay. So this is 900 and this is 150. So our velocity will be in what direction? It will be like this, right? So first we need to find magnitude. Magnitude is 900 square plus 150 square under root. Okay. And then, yes ma'am? We don't have to take. So we are taking plus only, no? And on 2.4. This is in kilometer per hour square. And then alpha is inverse tangent 150 by 900. Okay. Degrees. So compare it. Is it same? And before going to compare, let's see. We can just put the direction of velocity also. Velocity vj is minus net j, so it is acting in downward direction. Magnitude is 100 kilometer per hour. Direction is downwards. Okay. Is it same? What is given here? Solution 900i 150j, right? So 912.4, 9.46 exact. Yes. Then planar rigid body motion, translation and rotation. There are cases where an object cannot be treated as particle. Nano? Give me a minute. Nano? Okay, na? Mommy, yes, ma'am. So there are cases where object cannot be treated as particle. If the object is very, very large, then we cannot consider it as a single particle, right? Very, very large. Like Earth, for example, we cannot consider it as, yeah. So with relation to the galaxy, we can consider it as a particle. But with relation to a car or plane which is moving, its size is very large, so we cannot neglect it. And for example, design of gears, cams, and links in the machinery or mechanisms. Rotation of the body is important aspect in the analysis of motion. Okay. So, do you know what is mechanism? Objects which move with relation to each other. Like you know about 4-bar mechanism? 4-bar mechanism or slider crank mechanism, something like this. Okay. So this point is moving in a circular path, right? And this point is moving in horizontal direction, right? So this arrangement is called as a mechanism. And here we cannot treat this rod as a particle because it has significant length compared to the motion that it is undergoing. So we have to find velocity and acceleration at number of points on it. Okay. Nano, door band kar. So which point to consider will be given mostly in the question, and according to that we must be able to find the motion. Okay. There are some basic kinds of motion given here at the beginning. Go through them first. Translation and rotation, these are the two types of motions. Okay. So if a body is moving in a straight line without undergoing any rotation, then it is called translation. So here you can see the path is curved. But the object remains in same orientation. Because of this, we can say that it is still just pure translation, no rotation. And if an rotation, no, it's not undergoing any rotation. Okay. Because the initial position is vertical, final position is also vertical. So it is called pure translation. And here you can see there is a fixed axis about which an object is moving, rotating. This kind of motion is called fixed axis rotation or pure rotation. Above the line we have pure translation, and on the left side below we have pure rotation. In some cases what will happen, both will change. The object will rotate, orientation will change, and also the object is displaced from one point to another. So such kind of motion he is calling it as general plane motion. Okay, I think he is considering the planar motion only. What is planar motion? If the motion is happening in a single plane, xy plane or xz plane or zx plane, then the motion is said to be planar motion. Here is explaining translation. What is happening, I've already explained to you. This is pure rotation, rotation about a fixed axis. And then this is a general motion wherein both rotation and translation occur. Okay. Then we haven't shown a mechanism here. This is the rod is undergoing general plane motion, है ना? Yes, rotation and movement both are happening. That is general motion. Whereas what about this slider? Yeah. So that is undergoing only pure translation, and here we have a rod which is rotating again. That as well can be called as rotation about fixed axis, right? So I had designed some mechanisms. Let me just show this to you. 4-bar mechanism, let's say. Okay, now the green link is fixed, right? The red link is undergoing pure rotation, isn't it? What about the blue link? Blue link is also pure rotation, but it is not complete 360 degrees. Blue link is also rotation, but it is not complete 360 degrees. What about the pink one? Also rotating, you see, angle is changing. Okay, so now it's nearer to horizontal. When we come here, the angle has increased, you know, it has almost become vertical. Rotation is happening as well as translation is also happening. So this one is a general plane motion. Red and blue, they are pure rotation about axis. Axis will be at this point, right? This, for blue it is at this point, for red one it is at this point. So that way you need to understand. Okay, here, and if we take a slider crank angle, we have slider crank. Okay, normal. Okay, mm, slider crank. Okay, let's do now. Okay, so here red link is called as a crank. It's undergoing pure rotation. Okay, rotation about fixed axis. And the slider, it's just moving forward and backward, right? This is translating. Whereas the pink one, now at this point it is horizontal, right? and when we come here it will be inclined, and also it is translating. So this is general planar motion. Yeah. Yes, rotation and translation both are happening. Right. This is what he is trying to tell here in planar motion. Then general plane motion, then curvilinear translation. Okay, so what happens here between these two is kind of like parallel crank mechanism. Parallel parallel crank means if blue length is same as this. Okay. Now I with this. Okay. Now what about the pink link? Translating. There is no rotation for pink link, right? That is, yeah, yeah, beyond radar rotating. This is what he is talking about here. Okay, this link. That's why he's calling it as curvilinear translation. Because the radius of this and radius of this is same. R, you know. Where is fixed point? Which rod? This rod, this horizontal rod. Yeah, it's translating, and this translation is called curvilinear translation because you can see the center point is moving in horizontal direction also. The path of both the points is circle, no? Endpoints of pink link are moving on a circular path. That's why it is called curvilinear. So in the definitions here, that's what he has shown, right? Like here, you know, the path is curved, but the orientation remains the same. Then it is called curvilinear translation. Okay. So once again, we have to come down to the same analysis. Okay, so we have to take frames. We have to define the frames, and we have to define the positions with respect to the fixed frame. Those become absolute positions, right? And then if you want to measure motion of one object with respect to another moving object, then it is called relative position. That's what we need to analyze. So same formula we need to use. The difference is we are now applying it to the machines. Okay. So here is telling us how to find the direction of rotating velocity. Okay. You're getting it? So rotational velocity. Let's take an example of a fan, let us say. Okay. This, right? This is a fan. Now if I want, if it's rotating, right? It's rotating with, let us say, omega. And omega is scalar or vector? No, it's vector. Omega is vector. Okay. So if it is vector, then we should know the direction, right? If I take a point, some point, let us say a point, It will be moving tangential, right? A point will move like this, perpendicular to the line joining center, है ना? This is velocity of A. But I'm interested in the direction of omega. Direction of omega. So can we take this as the direction of omega? Yeah, we can't say like that, because when the point comes here, then its direction will again change, है ना? If the point is here, the direction will be different. So direction of omega, if you want to find, it will be, perpendicular to the plane in which I am drawing. So it will be either towards us or away from us. Okay, so which direction it is? How to find whether it is towards or away? So that's what is explained here. Okay, yeah. So if you keep your fingers in the direction of rotation, then thumb gives us the direction. And if the rotation is opposite to our fingers, what will happen? The thumb will point downwards, right? That way, we have to use the right hand rule to find the direction of rotational, or okay. So d theta means displacement. D theta is displacement. What is alpha? Angular acceleration. And omega? Angular velocity, rotational velocity. So what are the units? Units for displacement? Radian. Unit for omega? Omega is d theta by dt. So this will be radians per second. And for alpha, alpha is d omega by dt. Or we can write it as second differentiation of theta. And its unit is radians per second square. Okay. So these terms are clear. And for all of these, we have to find direction by using right hand rule. Okay. For direction, we have to use right hand rule. Okay. Yeah. That's what is explaining. You see, omega is this. Now it is counterclockwise. Counterclockwise when seen from top. No. When seen from top, it is counterclockwise. That is taken as plus. Okay. Plus means upwards. Okay. Same way alpha is like this. But if omega is decreasing, okay, suppose omega is in this direction, okay, but omega if it is decreasing, first let us find the direction of omega. Omega is towards us or away from us? Away from us. And if omega is decreasing, then what is the direction of alpha? If omega is decreasing, then alpha will be in this direction, no? Yeah. Deceleration. So if omega is increasing, alpha direction will be same as omega. If omega is decreasing, then alpha direction will be opposite to omega. Opposite. Yeah. That also we need to be careful. He's explaining all this stuff. So these are the equations of motion. Okay. We had seen. Yeah. If omega is decreasing, then it will be opposite direction. Okay. Then these three equations of motion we had studied now earlier for linear motion. The same equations are now defined for sorry. Your voice suddenly your voice has reduced. Can you fix it? The volume has gone down. So maybe the wire got disturbed or something. It's low. Okay, let's continue. Speak a little louder. Okay, that will be enough. So these equations are same as before, right? What were the equations for linear motion? V equals at. Now for rotary motion, V will be replaced with omega. V naught will be replaced with omega naught. A will be replaced with alpha. S will be replaced with theta. Same equations. Same equations. If the acceleration is constant, these are the three equations. If again acceleration is changing, then it becomes a different matter. Okay. You cannot use these equations if the acceleration is changing. Yeah. Now we can write this same equation. We can write as omega equals omega naught alpha. Okay. In the second equation, S equal to S naught plus V naught T half. The same equation now here what happens? Theta. Hmm? 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 Understood now? So the same equations, you just need to convert them like this to get rotary motion. So this is for linear and right side is for rotary. Okay. So these are the three equations. So 1 by 2 is writing it as 0.5. Can we write it now? Then rigid body rotation. So he's giving the relation between peripheral velocity and omega. Okay. R. R is the radial distance of the point from center. Same way, acceleration sorry V equals omega R. Yes. Yeah, velocity in rotatory format. Right? Let us take a link here like this, and let's say that this link is rotating with omega. Okay. Then we are interested in finding velocity of this point. If we call this as O, this as A, this becomes velocity of A, right?
तुम टीवी का नेट बंद करे क्या? नहीं
Okay. So the relation between this velocity and this omega is this. Okay. Where r, what is r? R is this distance. Okay. R is this distance. So from this point to this point, that distance. Okay. Same way, if you have alpha, okay, you have alpha, then you can find tangential component of acceleration. Okay. So tangential component of acceleration is alpha times r. Okay. And normal acceleration as usual, it is v square by r. Okay. Combining these both, we will get total acceleration. Clear? Then here we have tangentially, see, correct? And normal acceleration he has written in terms of omega. So if you substitute this value here, what we will get? Omega into r whole square, no? So one value of r will cancel. So omega square r can be written. Okay. Is this clear? Then now here he is asking, when he's explaining how to find accelerations. No? This is alpha r. Okay, he's expanding this. Acceleration is d by dt of velocity, no? And velocity, formula for velocity is omega into r, right? Both are changing. If both are changing, then we have to take uv, right? Omega into dr by dt, okay, plus r into d omega by dt, right? This is r into, yeah, this is r into alpha. Then what is dr by dt? Dr by dt is another velocity, no? Velocity in perpendicular direction. That perpendicular direction velocity is calling it as omega into r. Okay. So this becomes omega square r plus alpha into r. So this becomes the normal acceleration. This becomes the tangential acceleration. Okay. That is explained here. Rotation about fixed axis, or the same equations are repeating. Then example here. Okay. Motor turns the gear A. Where is the motor? Yeah, motor is situated behind this. Okay, here we have the motor that is rotating the gear A with constant angular acceleration alpha A. Okay, and alpha A value has been given as 4.5 radians per second square, and it is starting from rest. Starting from rest means theta naught is 0. Theta naught is 0 and omega naught is also 0. The cord is wrapped around the pulley D, which is rigidly attached to gear B. Okay, that means the drum D is rotating along with B. They are welded together. They are single objects. Okay, and he is now asking us to find velocity of cylinder C and its distance it travels in 3 seconds. Okay, so gear A is rotating in this direction. So gear B will rotate in this direction, right? And this will be lifted up. C will be traveling upwards, correct? So we need to find the velocity of C and the distance it travels in 3 seconds. Okay. So first, omega naught is equal to 0. Time is given as 3 seconds. Okay. And then alpha A is 4.5 radians per second square. Mhm. Okay. After t seconds, let us find omega first. Omega of A, no? So omega A, let us find. Omega A is equal to omega A naught plus alpha t, right? Initial velocity, omega A naught. Initial velocity is 0 because it is starting from rest. Alpha A is how much? 0.5 into 3. So we get 13.5, no? Radians per second, right? Then alpha A is given. Now with the help of this, we have to find velocities of B. Omega B we need to find. Then alpha B we need to find. Okay. How to find this? Omega B will be velocity of P divided by radius, no? Which radius? This radius of P, 225, right? Velocity of P by that radius is omega B. And this velocity of P will be same from the other side also, no? This velocity of P can be written as omega A times this radius, 75, no? 75 is the radius of smaller gear, right? So we can write Vp like this. Can we write it? Yeah. Vp is the velocity and Vp is same for A as well as B. So first we converted angular velocity of P into peripheral velocity Vp. Then we converted peripheral velocity into angular velocity of A. This 225 remains same. Now simplify. Can we simplify? 25 3 is a velocity of P. P is common for A and B. Okay. And Vp velocity should be same for A as well as for B. That's why I've taken like this. Now 3 is a. That means this is velocity omega of A by 3. Okay. Same way we need to find alpha. Okay. Alpha, you can just write similarly. Similar to omega B, you can directly write alpha B equals alpha A by 3. Okay. Now, yeah. So omega A is 13.5. So 13.5 by 3. Alpha A is 4.5. So 4.5 by. Okay. So 4, 3 4s are 12, 3 5s are 15. 3 1s are 3, 5s are, right? That means omega of B is 4.5 radians per second, correct? And alpha B is 1.5 radians per second square. Initial velocity for B is also 0. Okay. Now we need to find the velocity of C. Velocity of C will be omega of D into the radius. What is the radius here? So omega T into 125, correct? Now omega D is same as omega B, no? Because they are both welded together. So into 125. Substitute 125 mm. This is mm. So substitute omega B also. What do we get? 4.5 into 125. This will be mm per second, no? Much 562.5 mm per second. Okay. This is the final velocity of C. Initial velocity of C will be 0 because it is starting from rest. Now we are interested in finding the displacement. The displacement, yes, will be equal to initial velocity ut, ut plus half t square. So we need to find A also. What is A? A will be alpha of D into distance, again 125. Alpha D is how much? Alpha D is same as alpha B. Alpha b is 1.5. 1.5 into 125. What do we get? Sorry, 187.5, and this is radians per second square. Correct? Not radians, not radians. What would you get? This is linear acceleration, no? Mm per second square. Now both these values substitute here. Initial velocity is 0, so 1 by 2. Acceleration of c. Acceleration of c is 187.5 into time. What is the time? 8. Can you be a little louder? I'm not getting a sound. 8 not 3.84. 843.75. 843.75 unit. Oh, this is distance, so just and displacement direction will be upwards. Okay, Magendra, can we stop now because I'm not feeling well today, and we need to fix up a schedule also for our classes. So 7 to 9 is okay for you daily? 7 to 9, or we can take sorry, 8 to 10. Which one would you prefer? 7 to 9 daily. So let's just fix one and be fixed at that. Okay, this is final, 8 to 10. Okay, I'll inform them the same, and let's meet at same time daily. Okay. Okay, then so we'll stop here and see you in next class. Okay. Bye.
पापा पापा मैं रास्ते में क्या देखा मालूम उधर बिल्ली को कौन तो मारे से थे फोन भी आया था उसको बहुत